Quick accept.
Okay, problem 50. Please ready for advance on the board. Okay, you can start.
Hello everyone, I'm Wang Siru from Chinpoker International National Senior High School. Today I'm going to report paragraph 15, volleyball. There's problem statement. When you strike the side of a metal ball containing some water, you can hear a characteristic sound. The sound changes when the water in the ball is moving. Plan and investigate the phenomenon. And I have two hypotheses. The first one is what is the mechanism of the sound. And the second one is how do the relevant parameters affect the sound. And there's our experiment setup. First, we use pendulum to connect with the bouncy ball, and then use direction microphone to get the sound, and strike the ball by releasing the bouncy ball from the same position in every experiment. And when we shake the ball, we pass the tape on the wooden bar to make scale. And then we put the steel ball on the acrylic sheet to shake it. And about the shaking frequency, we use measurement to control it. And about the shaking amplitude, we control it between the tapes and use checker to double check it. And the shaking process is like this. And there's our experiment about definition of fundamental frequency. And this is our experiment video. After we import this sound into Audacity, then we will get a picture like this. And then we select this range to analyze the frequency by fast Fourier transform. And then we will get another waveform like this picture. And as you can see, there are many waves in the picture. And we define the first wave to be the fundamental frequency, and we define the others to be the harmonic. And there's my observation about two states of water. And this video is when the water is stationary, and the sound will be like this. And this is the video when the water is moving. And by Audacity, we can get the waveform like this. And the x-axis is time and the y-axis is amplitude. And we can see when water is stationary, the waveform will not undulate. And when the water is moving, then the waveform will undulate. There's my observation about undulation of wave. From these four pictures, you can see the undulation is increasing, and we define the lowest undulation as a benchmark. Then calculate the ratio between the lowest undulation and others. And during this process, we also find the sound will also change like this. From this chart, we can find that when obviousness of undulation increases, then the wailing sound will also increase. And there's observation about water volume. And from these four pictures, we can know when the water volume increases, then we can get this chart. Then the x-axis is water volume and the y-axis is undulation ratio. And from this chart, we can know when water volume increases, then the undulation of ratio will also increase, so the wailing sound will also increase. And this is the change of frequency about the standing wave. And the first part is when the standing wave in one dimension, and it will be like a string, and this L is the wavelength. And by this equation, we can know that when wavelength increase, then the frequency will increase. The next part is when the standing wave in two dimensions, then it will be like a plate. Then the length and the width will also increase. And from this equation, we can know when the length and the width increase, then the frequency will increase. And the final part is the when standing wave in 3 dimensions, and then it will be like a ball, and the length and width and depth will also increase. So from this equation we can know the frequency will decrease. So we can know when the water volume increase, the frequency will also increase. And this our process about the welding sound. When the boxing ball strikes on the ball, then it will cause very different frequency. And the standing wave will last long while others interfere and disappear. And in this chart, the x-axis is water volume and the y-axis is the frequency. And we can know when water volume increases, then the frequency of the welding sound will increase. And this is the sound when the water is stationary. And there's a stationary water about the big frequency. When the water is stationary, the waveform will be like this. And this chart, the x-axis is time and the y-axis is amplitude. And in this picture, then the x-axis is time and the y-axis is frequency. And we can find the length of each wave is the same between these two pictures. And the waveform about the two, when the water is moving, the waveform will be like this, and the sound will be like this. And when water is stationary, then the wavelength will not undulate, so we will not define it to be the welding sound. And when water is moving, then the waveform will also undulate, so we define it to be the welding sound. There's our data about the state of water, and our manipulated variable is the water moving or not. And we control the size of the ball, the temperature, the position, and the movement. And in this chart, the x-axis is water volume, and the y-axis is the frequency. And from this chart, we can find that when water volume increases, the frequency will decrease. When the water is stationary or shaking. But when the water is stationary, the frequency will always bigger than the shaking water. So we want to explain what reason caused this phenomenon. So we change the tilt angle. And in this chart, the x-axis is the theta, like this. And the y-axis is the fundamental frequency. And the different colors stand for different water volume. And from this chart, we can know when tilt angle increases, then the frequency of welding sound will decrease. And there's the data about shaking frequency. We change the shaking frequency, then compare the different water volume. And in this chart, the x-axis is shaking frequency, the y-axis is the undulation ratio. And we can find the lowest welding sound will appear in the range of 170 to 190 BPM, like this. And this is the critical value about shaking frequency. And the x-axis is the amount of the water, and the y-axis is the frequency. And the blue part is the frequency that can make the welding sound, and the yellow part is the frequency cannot make welding sound. And when the frequency is too low, the waveform will be like this, and the sound will be like this. And when the frequency is too high, the waveform will also be like this, then the sound will be like this. And from this result, you can know water volume increase, the welding rate will also increase. And there's the undulation of waveform. And from this chart, we can see the frequency will undulate. And we investigate the reason. And the first reason is when we shake the ball, the tilt angle is always changing. And when the tilt angle decreases, then the frequency will increase like this. And when it is from balance to tilt, and the tilt angle will increase, so the frequency will decrease. And another reason is the cross vibration. And in this chart, we can the x-axis is shaking frequency, and the y-axis is the frequency of the wave. And we can know the welding sound frequency will
component, your image.
Page 4, right? So the stationary water and the shaking water experiment. And when we want to conduct the stationary water experiment, then we will put the ball on the same position, then release by to strike the ball by releasing the bouncy ball from the same position in every experiment. And when we want to shake the ball, then we will control the shaking amplitude between the taps, then use shaker to double shake.
Cats,
Um,
stage or
not just to control the shaking amplitude.
cat is if you use about the time, then you
No, it just we test it on the wooden board, so it will change. And the two tests is parallel.
I also want to know shape effective and you use hand or
Use hand.
use hand
Yes.
and how to make sure that your attitude is still the same.
Use shaker to double shake.
Because your hand still has maybe still have a little different, maybe less shape.
Then it is
Time is not solid.
My name is Zhen Yongqiao, and our team is Huayang A. And we are from National Zhanghua Senior High School. And today we are talking about rolling ball. So, problem statement. As you see, when you strike a side metal balls constantly somewhat, you can hear a characteristic sound. The sound changes when the water in the ball is moving. Explain and investigate the phenomenon. And the main focus is what causes sound and what parameter will affect. And I think we propose is many experiment data and the chat clearly and they elucidate the information, but in-house don't have to experiment to set up and lack of field. So conclusion: design of welding sound away from the micro-oscillation welding and lead to SHM as friction. So this is our conclusion. So now I want to make some questions. I want to make sure that the water is not when you measure the experiment or you didn't focus on maybe you can in a box. Yes. And the water is inside. And don't know the water is virtually either.
And when the water is stationary, yes, it will change because we put it on the table. Yes.
So I want to make sure your step up is the water filter. Your step up before you do your experiment. Also, before you do your water.
Water is stationary.
You say pulse,
Yes.
ball,
Constructed balls.
straight ball, and does the location will act on ball.
It will not rotate.
And I also know when you use your hand to hide the ball, just like
It has the acrylic sheet. We will not touch the ball. Acrylic sheet is a board on the when we are shrinking the ball, the tilt angle is always changing. So in this data, in this data we show that when the tilt angle increases, then the frequency will decrease.
What kind of tap tool you use?
Tap.
Yeah. And
It will not affect the result because it just pressed on the wooden board. It will not affect the experiment process. The tape.
no, the tapping tool, like the ball.
But we didn't change it.
I said, what kind of tapping ball you use?
Oh, the
The
same.
tapping tool you use.
The same. The bouncy ball. We didn't change.
And how do you ensure the water volume is constant in each room?
What do you mean? Because when the water volume is are one of the manipulator variables. So, but in different experiments we will fix it. We will not change it. Just to compare it with them.
How do you ensure? Have you considered the impact of water surface tension or velocity on the result?
But it will be affected by the shaking frequency. So I think it is not important.
You can show you
Sure, what?
your result. Have you
Consider what?
consider the impact of water surface tension or the velocity of the result?
Velocity. I think it will not affect the result.
So you haven't considered?
Yes, but it is not important.
And have you tested the balls made from and how does the factor change the listen? I want to know if the ball's shape change I want to know the ball's shape.
We didn't change it.
I know, but I want to make sure the ball's shape.
Like this.
Is your shape like the pot? In your
Just a big ball. Yes. But we fixed the shape of the ball, so I think it will not affect my result.
why?
Because we fixed it.
So
Sorry, I think you want to focus on my experiment data. Okay. So we try to talk more about the experiment data.
I also want to know why this frequency has why does sound always
Because the unsplit ratio is the highest.
and I also want to know how the result is because you get shape to type I want to know why does it can you explain why is this overlap?
Because shrinking range, the frequency of the welding sound will also be different. But we just focus on the obviousness of the shaking frequency, and we find the 170 to 190 frequency is the lowest welding sound.
So, what you want frequency? I don't want to know.
You say mean why it will increase? Because when the shaking frequency is too low, the waveform will be like this, and when the shaking frequency is too high, it will be like this. So it will be like a critical value.
So it is what is
X-axis is time and the y-axis is frequency. Yes.
the 9 is
That is the frequency. Yes.
and does any energy go into both time and both?
Can you repeat again?
Does any energy goes with the both time?
But we just focus on the change of the sound.
But I think that is important to
It will only affect the decibel of the sound, but we focus on the frequency.
because if you ignore that, I think
But I think it is not important because it will affect the decibel of the sound, but I think the frequency of the sound is the most important in my experiment.
turn to test page.
Page.
So I want to make sure what is
Because when the bouncy ball strike the steel ball, then the vibration of the steel ball will affect the vibration of the water. So so it will make this result because of the force vibration.
So you use the shaking frequency and get a result to the test station.
Yes.
So we can use formula to measure.
When the water is still and the force will be like this.
Why is
Acceleration and this
Time is 1 minute. It's already.
so after our discussion, the reporter thing, water on the surface and tangent doesn't important, and when the energy is losing, and we also think we need to focus on the frequency but not the energy losing. And they say, and they use SH. I asked how to they use their blackboard to describe the SHN, and also
Time is start. The bureau will have no touching. Close.
So I want to ask reporter, do you integrate the Taupen result and the still result together, like to simulate what the water is moving?
no.
So then, okay. Do you know natural frequency?
yeah.
So do you think that the natural frequency is in fact this?
I think you will.
Do you know natural frequency?
Yes.
And do you think it affects this phenomenon? the problem statement have mentioned?
I think you can
Like, what's the main factor?
use the frequency to explain the
Other factors or only frequency?
I think changes in the frequency control explore that.
Can you repeat again?
What do you think that most affect characteristics? Like,
What factor does the really sound?
yeah,
I think it's
like all of the factors, not only the most.
the tilting.
Have you considered the standing waves and resonance? Have you considered the standing waves and resonance
Yes.
in your experiment?
Because when we increase the water volume, then the frequency will be more lower.
Yeah, but you didn't explain about the resonance, like standing waves.
Because we only focus on the frequency of the sound.
Okay, so for reviewer, personally think that those are also some factors that form the characteristic sounds. So, do you control the striking force and the striking point?
Yes.
Do you like quantify it?
Because we release the bouncy ball from the same position in every experiment.
Okay. Do you think that the position of the microphone will affect the result?
But we fix it.
Do you think that position will affect?
Yes.
The microphone.
But it will also affect the decibel of the sound. It will affect the frequency.
Time is up.
Thank you.
2 minutes duration. Okay. Real objective vote.
Honorable judges and fellow competitors, I'm Lei Tsai from Haha. And this is the problem statement. And the main focus of the report is the main reason of the sound and how the relevant parameter affect the sound. And here's an overview of the reporter's presentation. So their observation is the freezing spot and B equals to F lambda. And the experiment method is bouncing ball to form the edge and moving water and the tilted angle or not. And the data analysis, they data two states of water. And for conclusion, they said that the frequency of stationary water is always bigger than moving water. And the tilted angle increases, the frequency decreases. And the shaking frequency equal to frequency of the blowing sound. Here are the pros and cons of the reporter. Reporter have prepared their results and clear demonstration and explanation about results. So the cons is that lack of the reality pictures of the setup and lack of quantifiable sound. And the theoretical pros and cons of the permit. We have a thorough discussion, but the cons is that they cannot express their ideas clearly. So I didn't really get what they really want to express. And the discussion, they have discussed about the ball rotate, and the reporter said that no, but the reviewer's points of view, we believe that the water will rotate. And they have discussed about what's the ball, the material affect the result. And the reporters said that they didn't really focus on that, but we think that that's a very important variable. And the opponent asked the reporter about the main factor of this phenomenon, and the reporter believed that the frequency is the most important factor of this phenomenon. But the reviewers believe that the material and the rotating speed is the main factor, since the material further affect the natural frequency of the ball, and the rotating speed will affect the welding sound. And we have asked that what factor does they consider when forming the characteristic sound? And the opponents say that the frequency is the main factor, and the reviewers say that the tilted angle is the main factor. And the reviewers, just like I mentioned, we believe that the material and the rotating speed is the main factor. And they all believe that the material will affect the result of the experiment. But the reporter don't think that is the main factor. But we believe that the material is actually a very important variable. And they all know about the natural frequency. Yes. And we have asked them about how do they standardize the striking force and the striking point. And they use pendulum. But we believe that even though using the pendulum, we should, because pendulum will also have many uncontrollable factors, so we believe that we should quantify the striking force and striking points. And they didn't really focus on standing wave and resonance, which we believe that really create that characteristic sounds in this phenomenon. Thank you.
There's concluding remark, and reviewer asked me the material of ball and the rotation will affect the result a lot or not. And I think it will affect the result, and I use it to be my control variable, so it will not change. And she just focused on the material of ball, didn't affect another factor. And about the opponent, she just focused on the experiment setup. But and about the strike position and the strike force, I released the bouncy ball from the same angle and the same positions, and so I release force and the release position is the same in every experiment. And in my main focus, I just say what is the main reason of the sound, and I got it. It is the tilt angle, and I focus on how do the relevant parameters affect the sound, and I found the tilt angle and the water volume will affect the result. And the reviewer just asked me the effects of standing wave, and I think I just focus on the frequency of the sound, and the water volume will change the frequency. And we find when the frequency of the water volume increases, and the frequency of the welding sound will decrease. And the welding sound will also be more obviously, and the welding rate will increase. But they are not focused on it, they just focus on my experiment setup. And I also find when the shaking frequency increases, then the frequency of the welding sound will be equal to the shaking frequency. And when the tilt angle increases, then the frequency of the welding sound will decrease. And I also define the difference between the beat frequency and the welding sound. Thank you for your attention.
Okay, it's time for our discussion.
There's a simple way for the problem. I think the main purpose is to find how the sound change when the water motion is moving, right?
Yes.
Then what is the relevancy with that How is the relevant to this problem, to the picture?
Because when we are shaking it, but the water volume is different, it will also affect the change of the sound.
Okay.
Any other questions?
Personally, in my experience, I also measure the frequency of the tilted position. So actually, I think tilted position is the simulation of one of the stop of rotating. Like when it's rotating, some points that are tilted. So when you combine all the tilted frequency and the straight frequency, combined together, we can simulate the motion.
So, yeah, since you asked, then I also have a question for the viewer. I thought you asked me the question about resonance. What is this question relevant to this problem?
Actually, I think resonance will not straightly affect the frequency, but the resonance will affect the other character. Since the problem statement said about characteristic sound, so I think resonance is actually will affect that volume and the humming sound. It might not straightly affect the frequency, but it will affect another factors.
Okay, finally, I want to say the page 15, please. So, can you explain the y-axis, why the frequency, the units of PF4? No, this one. Left one, yes.
Because each wave stands for a different frequency.
So it means the units of frequency is dB.
Because when it is highest, and then the decibel will be the most.
Okay. So it's time for the story. Please wait. Okay, now first, for the principal storyboard, 6, 7, 4, 8, and 6. The second one, show the 4, 4, 3, 5, and 5. Final for your please show 6, 7, 6, 7, and 6. It's okay. Thank you for sharing this. This files.
好，那我们接下来要收集 reporters 的报告的 slides。So, 廷威、于谦 and 思鲁 please bring your data and come to me. I will copy your slides. 然后桌上的 laser pointer 笔就帮我留在原本的座位上。